Thanks everyone for joining me today. My name is Hassan Barakat and I work as an engineering manager with a company called Willow here in Sydney, Australia. This is my Twitter handle and website if you would like to follow me or reach out to me with any questions that you have. My plan for today is to talk to you about building infrastructure as a code for Azure platform with .NET Core. So we'll learn what is infrastructure as code, how can we use C# to provision our Azure resources. Let's start by trying to answer the most important question, which is how to provision cloud resources. Historically, we used to deploy the manual or the click ops or the point and the click where you open the Azure Portal and then you have a form like you would like to create a virtual machine. You say, all right, I would like to have a virtual machine with that amount of CPU, this amount of memory, disk space, click submit. Few moments later, you will have the virtual machine or whatever resource you requested. But after a short time, we all learned that we shouldn't have done that because all of these ClickOps resources usually tend to end up as part of a Snowflake servers or Snowflake resources, where you have like production environment with bunch of configuration totally different from UAT or dev or pre-prod. And this is usually the source of bugs that are hard to produce and hard to troubleshoot. So as a community, we moved into the infrastructure as code approach. The idea of infrastructure is pretty simple. It's managing and provisioning cloud resources using code. We started with the imperative approach, which is using the CLI commands of the Azure CLI or PowerShell or Bash scripts to provision our resources. And that was a big improvement from the ClickOps. However, over time, the amount of code that we had to maintain kept growing because by nature, the projects that we work on need more resources. And not only that, the complexity also started to increase because we needed to have some sort of error handling. So if the script failed in the middle, I can rerun the script again without resulting in duplicate resources in my Azure account. So we needed to have error handling, idempotency. If I'm dealing with a temporary environment that I would like to destroy later, I had to build yet another script to destroy those resources. So although the imperative approach was big improvement from manual, it still had a lot of complexity into it. And that led us into the declarative infrastructure as code tool, which we as software engineers have done what we usually do best, which is applying abstraction concepts to all of those common concerns that we had to apply for each resource. So right now, instead of us writing all of those imperative scripts, we use the desired state. We just describe, I would like to have a storage account. I would like to have a virtual machine. I would like to have an Azure function. And it's the responsibility of the tool to apply the delta to compare the desired state versus the actual resources that exist in Azure and determine what kind of commands require to be done to move from the current state into that desired state, be it creating resources, updating them, deleting, whatever is needed. There are multiple declarative infrastructure code tools available right now for us in Azure, like Azure Resource Manager, Terraform, Bicep, in other cloud environments like CloudFormation and Google Deployment Manager as well. However, as a developer, I have struggled a lot with those tools because they are based on formats such as JSON, YAML, or domain-specific language. The way you describe the resources in those JSON or YAML files are really not intuitive, and it's hard to memorize them because it's not easy for us to relate with or resonate with those kind of languages. Good news is there is another way. We don't have to deal with YAML all the time. And this is what we're going to do today, which is using Pulumi. Pulumi is an open source infrastructure as a code tool that enables us to use real languages such as C#, TypeScript, Go to provision our cloud resources. Once we decide to go with Pulumi or using real language, actually, we have a lot of benefits such as control flows, loops, and if condition. That's out of the box, nothing to be learned there. If I would like to apply abstraction to the functionality that I have built, I can use functions, classes, or packages. If I build an abstraction that might be beneficial to other teams in my company, I can share it via package management like NuGet or npm. I can write that infrastructure code using my favorite IDE, which provides me with refactoring, code completion, and static type checking. I can even use my favorite testing framework to write unit tests and integration tests on top of my infrastructure code. So there are heaps of benefits just by changing the mindset from using JSON, YAML, or domain-specific language to using real programming language. So these are a lot of benefits. I would like to show you all of these benefits in action right now. So let's switch to the terminal here to show you how would we start with Pulumi. Pulumi is, in order to start with Pulumi, you need to install a Pulumi CLI, which is a cross-platform CLI tool. And the first thing to create a new Pulumi project is Pulumi New. This shows me a bunch of templates to choose from. Pulumi supports multiple cloud environments. Today we are going to use Azure with C#. Pulumi will ask me for a few parameters to pass. I will just use the default and I will walk you through what these parameters are. I'm in Australia, so the closest region to me is Australia East. What's happening right now is Pulumi is creating a .NET Core project for me. Let's open the Visual Studio Code to see what has been provisioned for us. So here's the Pulumi project. Pulumi created the .NET Core project for us. It has one NuGet package referenced here, which is the Azure native. I have a Pulumi.yaml file, and that file has like 3 parameters. The most important one is the runtime, because this is telling Pulumi which language or which runtime we are using. Pulumi supports Node, like I can write in TypeScript, or I can type in Go if I would like to. So this is important to tell the CLI which runtime we are dealing with. We have this Pulumi.dev YAML. This is the stack YAML file. Think of a stack like an environment, and each environment could have its own configurations. As a developer, I'm sitting here in Australia East, so the location of my resources will be in Australia East region. However, I could have my production environment with the location of the resources set to Europe, because my end users are in Italy, or they are or I can make the production to be in US because the end users are in US. So this is enabling me to configure my environments. Then we have my stack, and this is where the actual code exists. This is how I create the resources. We have here a resource group, and to create a new resource or any type of resource, it's just a class instance in C#. So to create a resource group, a new class instance, and I pass the name of that resource. I would like to create a storage account. It's another class instance. Provide the name. If I have more parameters that I would like to use, like which resource group that storage account will sit in, I pass this as another parameter here, the stock keeping unit and the storage and the kind. We will cover the output parameters or the output properties in later today, so I'll just remove it for now to avoid any confusion, and we'll get back to it in the next demo. So here I'm going to create 2 resources. How can I provision those 2 resources? I can use my Pulumi CLI to use Pulumi up. Pulumi right now will compare the desired state, which is what I have in my C# code, versus the current state. The current state is what I already have in Azure. And since this is the first time to run this code, the current state is empty, nothing exists. So Pulumi is telling me that it will create all of these resources. I will go with yes. And you might be wondering right now, how did Pulumi know which Azure account and subscription to connect to? There are different ways to provide the Azure subscription to connect to Pulumi. Right now, because I didn't provide any parameters, it's using my Azure CLI token. I used AZ login to my account, and it's using that token to provision the resources. I can also pass those parameters via like which account and which subscription to connect to via environment variables. But right now I'm just using the CLI token. So the two resources has been provisioned. Let's go to the Azure portal to verify those two resources. We zoom in a little bit here. Okay, we can see a resource group created, but there is a random string at the end of that resource group. And that random string is a default behavior from Pulumi. So if you run the same program multiple times, the resources will not be collision because of they have the same name or anything like that. That's a default behavior. We can disable that default behavior, as we will see later today. Here is the storage account, has also been provisioned inside my resource group. So I have provisioned the storage account. Usually you would like to exchange these resources after you provision them because the requirements change. So let's say right now I'm using locally redundant storage, and over time I would like to make it a higher availability replication option. Instead of locally redundant storage, I would like to go with GU redundant storage. To do that, I don't need to have if conditions. I don't need to check if the resource exists or not. I just describe the desired state. Since I am in the Visual Studio Code, it's giving me the code completion. It's giving me all of the options. I'm going to go with GU redundant storage. And to update the resources, I follow the exact same process. All what I have to do is run Pulumi up. Right now, Pulumi will compare the current versus the desired, and it will find that there is only one change happened, which is the stock keeping unit of the storage account. If I click on the details, it's even telling me it was locally redundant storage, and it will be GU redundant storage. Right now, this will go and update the storage account. It usually takes a few seconds to do that. Here you go. Now, if I refresh, keep an eye on that locally redundant storage. It has been updated to GU redundant storage. So you can see it's pretty easy to get started with Pulumi. Not a big learning curve that we have here. This is a very simple starting point for Pulumi. Usually your application will be a bit more complex. But before we get into a complex sample, let's cover what we have learned so far. When we started with Pulumi new, that generated a .NET Core project for us with a pulumi.yaml file. That's what we call a project. The pulumi.yaml file had the runtime and the project name. We also had the stack YAML file. Stack is an independent instance of a Pulumi program. We usually use it to represent different environments. I can add multiple stacks using Pulumi stack init, and each stack will have its own YAML file. I can use that stack to have different configurations for each environment that I'm dealing with. If I would like to add a configuration for a particular stack, I can use my CLI Pulumi config set, provide the key and the value for my configuration. This will update my Pulumi stack configuration file or YAML file with those keys that I'm adding in here. I can access those values via pulumi.config and then use this class instance to call the method required to be able to retrieve those values from the stack YAML file. So those are the three important concepts to keep in mind when you start with Pulumi. So we have seen that pretty simple resource group and storage account. What if I would like to extend my sample to have that storage account hosting a single page web application? And let's say I'm using microservices, so I would like to have more than one storage account hosting single page application. How can we do this, and how can Pulumi help us have that abstraction implemented in the code? Let's see that in action. You would expect that to provide that static website, there is some sort of a property here. Let me show you in the Azure Portal, how would you enable the storage account? It's nice. Here's static website. If I click enable, I need to provide the document's name for the index and the error document. Once I click save, Azure will create a specific container called web, where I can upload my static files inside of it, and it will also provide me with a URL that I can use to access that storage account. So you would expect there is like a static website property enable and disable in my storage account here, but there is no such thing. The reason of that limitation is the underlying API from Azure doesn't expose that property yet. However, Pulumi has provided us with an alternative resource. That resource is kind of a virtual resource, which is behind the scene, is making a direct call to the Azure API to enable the static website. It's like using the Azure SDK to do that. So let's see how can we do that in code. It's called storage account static website. You can see I'm getting the code completion here. I need to provide it a name, and I need to have the rest of the parameters. As we have seen in the portal, I need to provide the index document as well as the error document. But in addition to that, since we are in code, we need to provide the resource group name. We need to provide the storage account name. And you might be wondering that, like, how did I know all of these parameters? It's pretty easy to figure them out. You can see here, those are the properties of that class. It's not really magic, it's just simple C# class. I will call the index document index.html and the error document 404. With that, let's update our resources. This is now going to update that property for my storage account. I will go with yes. Awesome. If I refresh my storage account, I can see there is a special container has been created for me. Here is the URL that I can use to access that storage account. If I go ahead and access this storage account, I see nothing. And the reason is that web container doesn't have any files. If you are a developer using that infrastructure as code, you might not have enough confidence in the generated storage account and might be confused, okay, why am I getting this error? So to provide an easy way to verify that the storage account has been provisioned correctly, I would like to upload a couple of files, the index and 404 files, to give us that confidence after we provision the resources. And this will also show us other capabilities in Pulumi. I'll create 2 files to be uploaded. Something went wrong, and then here I'm going to go with Pulumi is awesome, because it is. Now in our code, I would like to upload those 2 files. Because we are in C#, I can use arrays. So I'm going to use an array to declare the files that I would like to upload. And in here, I will use index.html. And I actually missed the naming of that file. So it's going to be 404.html. Now I have declared the array. I would like to loop over this array. So I can use the code snippets from Visual Studio Code to loop over these files. And then I would like for each file to upload from my local storage to that web container. I have a little snippet here so you don't watch me typing a lot. It's a new resource that I can use. It accepts a few parameters like the plop name. We have a resource group name, account name, container, and other parameters. And we can see here where does the file exist in my local storage. Now, if I run this program, it will go and upload those two files, and I should be able to access the URL of that storage account to verify things are working as expected. Before we do that, I would like to do one more enhancement, which is in order to get that URL of the web container or the storage account, I had to open the portal, find that particular panel of the static web app, and like this one to be able to get to that URL. It would be handy if I can print this in my console, and that's what I'm going to do. So I will go with public, and I will use an output property or an output data type. The output data type is like a promise. The value of that promise will be available after the resource has been provisioned. And I will mark it with output so it gets printed in the console after we provision that value. We can, since it's a C# property, I can set this value. Normally accessing a storage account has something called the primary endpoints, which enables me to get all of the endpoints of that storage account. However, that primary endpoints is an output property as well. So to access the value of that output property, I need to use a special method called apply. And that apply enables us to access the raw value of those primary endpoints. So after the promise has been resolved, I can access the value of that particular property. So right now, the storage account will be provisioned. It will be enabled as a static website. The two files will be uploaded, and we will see the URL that we can use to access the storage account on the console. Gloomy up. There is a question about there is a way to make a soft migration from Ansible to Pulumi using existing YAML files. I haven't done that previously, moving from Ansible to Gloomy, so I need to check it out and get back to you on that. Right, we can see the two files has been uploaded and the URL has been printed on the console. Now, when I access the URL, I can see that the Pulumi is awesome, and also if I access the 404, I should be able to see something went wrong. So we can see here with Pulumi, we are improving our resources, and it's easy to comprehend. But this is like one storage account. What if I would like to have 2, 3, 4 storage accounts, all of them with the static website property enabled and the two files uploaded? This will be very messy because for each one of them I have to create four resources. Good news is, since we are in C#, we can start applying abstraction concepts. So I can create a new like virtual resource to encapsulate all of these 4 resources. So I can create something like public class static website. And this will be a new resource that I will create that encapsulate the 4 resources that we have for a storage account with a static website enabled. So in order to do that, we inherit from a class from Pulumi called component resource. And that class requires a constructor. The constructor here has the first parameter, which is the type. The type is what you see here in the command line or the console when you provision the resource. This could be anything. In my sample here, I'm going to call it my company Azure static website. And since I already hard-coded that value, I don't need the consumers of my class to pass that parameter for me. The refactoring is pretty straightforward. I will just move all of the 4 resources to be part of my class, including the property, because I want to expose that property as well. Sorry, I didn't cut. Here we go. And I also need the property, so I will copy that. So as we can see here, after the copy, there are few errors because the resource group name, I can pass this as a parameter to my class. And I don't need to do that anymore. One more thing I notice here is the names of the resources are hard-coded. They should be dynamic based on the name of my new resource. So as opposed to SA, it should be the name of the resource, or at least some sort of a convention that I will come up with. So I will update the 4 resources to use the name as part of their convention. So here I'm going to use name count 5. Nothing really fancy, just normal object-oriented refactoring here. Now we have created this class. We can go here and try to use it. So let's go create var app1 equal new static website app1, and I would like with that to go and pass the resource group name. So here is my app1, and I can call this just app1 or primary endpoint 1, because I will have 2 storage accounts just for the demo purposes. Sorry, I need to set the value of that primary endpoint first, which equal the app1.primary endpoint. Then I will create another storage account. Pretty straightforward. It's just another instance of that static website property, and I can set the value of the output properties based on that. So here you go. I have created the 2 resources, and each one of these will have its own set of resources to create the storage account. So let's go with Pulumi up. All right, we can see here, because obviously I have changed the name of the storage account, these should be deleted. And we see here 2 static websites. Each one will have storage account, 2 static storage account static website, and 4 blobs. It's very hard to understand which resource belongs to which static website. There is an easy fix for that, which is using the parent option. It's basically we go here and go and say parent options, which is a new custom resource options. We can define the parent of a particular resource, and then I can pass that parameter to my resources. This kind of gives us a nice hierarchy that we see when we provision the resources on the console. So this will just make these 4 resources to be children of the static website. So we can see some kind of hierarchy in the CLI. Here, Gloomy up. All right, we can see the Pulumi app has been created this better preview, because now I can see I have a static website with 4 resources inside of it, and another static website with 4 resources inside of it. So if I have 4, 5, 6 storage accounts that I would like to use to host single page application, I can easily do that. It's just another instance, and if I find that this is beneficial for other teams, I can go and create NuGet package, share it with other team members in the company. I will let that proceed, and we'll switch to the slide. This will obviously go and create all of these resources for us, and we should be able to verify everything inside of it. This usually takes like 30 seconds. All right. Cool. It's taking more time than I was expecting. It's fine. Okay. The storage accounts started to be created. Okay, cool. We can get back here and get back to the resource group, and we should be able to see the storage accounts popped up. One of the things that I have noticed that's very funny with the Azure Portal, the resources doesn't appear immediately. So sometimes you need to wait for a few seconds for the resources that you provision to appear inside the Azure Portal. Here you go. The storage account started to appear, and I believe it will be a few more seconds for the second storage account to appear. And instead of waiting, let's get back to the slides, and I will walk you through some of the other important things today. So far, one of the most common questions that I get from people that are introduced to Pulumi is, but with all of these for loops, if conditions, and control loop that we have in C# doesn't mean that that Pulumi is actually imperative approach rather than declarative. And to answer that, I would like to walk you through how Pulumi works under the hood. We use C# code to describe our desired state. And here we create like the storage account, the resource group, the SQL server, anything as a C# class instance. Then we pass that desired state to Pulumi CLI. Pulumi CLI will compare, okay, what is the current state versus the desired state. The state in Pulumi is just a JSON file. That JSON file can be stored on your local disk. It could be stored in a storage account. It could be stored in a Pulumi SaaS offering to have the state with that SaaS offering. The next step is Pulumi, after it compares the desired versus the current, it comes up with a plan. How would I reach from the current state to the desired state? That also includes how can I parallelize the operations. So while I'm creating the resources, I don't want to create them sequentially. I'm trying to parallelize as much as possible. After that, we go through the apply phase, and this is where the Pulumi CLI will go and make a call to the Azure provider to provision the resources. After provisioning the resources, Pulumi will update the state so that the next time we update our desired state, Pulumi can find the delta between the desired and the current state. If you look at any other tool that exists as a declarative infrastructure code, this is the exact same architecture. Like if you go and look at Terraform, you will find it's following the same architecture. So the short answer now for is it imperative or declarative? It's definitely declarative. We are just using C# to describe that desired state. So far you have seen me using my CLI on my local machine to provision the resources. This is not how you usually do it in your real project. You would like to have either like a CI and CD environment, regardless of what's the actual CI and CD platform that you will be using. The good news with Pulumi is the CLI tool that you are using in your local machine, it's the exact CLI tool that you will be using in your CI and the release pipeline that you will be working with. Even better, Pulumi has built a lot of integrations and extensions with the common platforms like Azure Devops, Octopus Deploy, GitHub Actions, and heaps of other platforms. Generally, the pipeline will look something like this. You will have your infrastructure code, be it the .NET code that you have written. Then you will run Pulumi preview, which is the first section to tell you what kind of changes will be applied if you were to proceed with those changes. Usually you will have like a manual step, and this is where you preview the outcome of Pulumi preview. And then you go ahead with Pulumi up. Pulumi up will go and update the infrastructure resources. Important thing is maintaining the state file. It's a JSON file. That JSON file, usually if you are in Azure environment, you will be keeping it in a storage account, or as I said, you can also use Pulumi SaaS offering to host that state. Here is a sample of the out-of-the-box GitHub action from Pulumi, which is running the command preview. the stack name is dev, and I'm passing here the Pulumi access token because I'm using Pulumi to host my state. And those are the configurations to tell Pulumi on my build pipeline which account to connect to and which subscription to use while you are connecting to that particular account. That's all what I wanted to cover today. So to wrap up what we have discussed, Pulumi is an infrastructure as a code tool. It's an open source and supports multiple platforms. It enables us to use real languages like C#, Go, and Node.js. It's a declarative. There are 3 key concepts to keep in mind. Pulumi project, which is the directory that includes the Pulumi.yaml file, stack, which represents your environment, and the configuration, which is the configuration of a particular stack. With Pulumi, we can apply abstractions to encapsulate resources using classes or custom resources or methods. Depends on what makes sense for our case. And it can be easily integrated with our CI or CD pipelines. For me, this is how I would usually prefer to write infrastructure as a code for any new project, because it resonates with me. It's easier to remember. I'm doing code all the time, so there is not a big learning curve for me compared to JSON or YAML or domain-specific languages. If you would like to look at the demos, they are available on my GitHub repository. The documentation of Pulumi is really awesome. They always have up-to-date documentation. The Pulumi GitHub examples directory have heaps of examples for a lot of scenarios for Azure and other cloud environments like GCP and AWS as well, if that's something you are working with. If you would like to access or to get the slides, they are available via this Bitly link. It's just Bitly, Pulumi Azure Day. If you have any further questions regarding the presentation, either ask them on the chat, I will answer them, or just hit me up on Twitter and I will answer them as well. Thanks a lot for your time today. That's all what I wanted to answer. I hope you have enjoyed the talk. Thank you.
Good, beautiful season, awesome.
Thank you.
We wait a few moments if push arrive the question.
Yep. There is a question, but I don't read. It's in not in English, so I don't really understand it. So
in this moment, I not arrived the question. If it's arrive the question, you speak the question.
Yeah, there is only one question that I see, which is there is a way to make soft migration from Ansible to Pulumi. Unfortunately, I haven't done that, so I don't have a solution or an answer for that question right now.
Ok. Ricordo a tutti i partecipanti che potete scrivere nel Q&A se avete domande per Osam. Ok, stanno arrivando delle domande.
Yep, there is a question of how can you run Pulumi project from Azure Devops pipeline? Actually, I have literally just done that before this talk. There is a task extension that you can install on Azure DevOps from Pulumi. And once you install that extension, you will have a task that you can use in either if you are using the CI like YAML files, or you can if you are using the release stages. It's Pulumi Azure DevOps task extension. Task is probably so you can see here the documentation of Pulumi have all of the details of how to use this task. So you can see here you can use it in the YAML file, or if you are using the releases, you can use it via the UI as well. Right. Pulumi compiles himself the YAML files when we write the C# code. Pulumi, if you are asking about the YAML file here, like that dev YAML file, this is not compiled. This is just the configuration values. Think of it like the app settings of your .NET Core application. It's just the format Pulumi uses to store the configurations. If you are asking if Pulumi generates like the YAML files or the ARM templates similar to other tools, no, it actually makes direct calls to the Azure platform when it provisions the resources. So it doesn't generate YAML files and then use the YAML files to call Azure. It directly calls Azure. All right, cool. Are there any further questions or we are out of time?
No, not other question. Thank you for your contribution at the next event.
Thanks a lot. Thanks everyone for attending. I hope you enjoyed the talk. If you have any further questions, feel free to reach out to me on Twitter and I will answer any questions that you have. Thanks. Enjoy the rest of the conference.
Thank you. Bye.